All right, so before we go into question 6, I've highlighted a bit of the textbook for you. There's some really useful things. This is obviously very useful. If you've got anything, say 0, so if I've got 10 things and I'm choosing 0 of them, there's only one way to do that. And I've got 10 things I'm trying to choose 10 of them, there's only one way to do that. If I've got 10 things and I'm trying to choose one of them, there's 10 ways to do that. If I've got 10 things and I'm trying to choose 9 of them, there's 10 ways to do that because it's the same as leaving one of them out. And then this one, slightly less useful, to be honest. We also have, I'll do it in a different grade, this property. If I've got 10 things and I'm trying to choose 4 of them, that's the same as though I've got 10 things and I'm trying to choose 6 of them. So, you know how Pascal's triangle, we had 1, 1, 2, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 5, 10, 10, 5, 1, 6, 15, 20, 15, 6, 1. This last one is saying that, these ones are the same, like on opposite sides, they're going to be the same. You know? That's all that's saying. So it's very useful, and you can, why can't I get rid of all of this? There we go. We're going to use that for 6a because they're saying evaluate 8c3 and 8c5. Well, 8c3 is 8 factorial on 3 factorial 8 take 3 factorial. 8c5 is 8 factorial on 5 factorial 8 take 5 factorial. This comes out as 8 factorial on 3 factorial times 5 factorial. This one comes out as 8 factorial on 5 factorial times 3 factorial. They're the same because 3 and 5 add up to 8. So we only need to chuck one of these in our calculator. I mean, you could do it by hand if you want. I'm not that motivated. So that's 8c3. That comes out as 56, and so will this one. I'm not going to bother doing number 2. It's going to come out the same way, okay? So if I have 6b, they're saying that nc3 equals nc2. That is n factorial over 3 factorial times n take 3 factorial is the same as n factorial over 2 factorial times n take 2 factorial. Okay, the only way that's the same is if these two, I'll do them in yellow or green, add up to this. Just like 3 and 5 added up to 8. So we know 3 plus 2 equals n, so n is 5. For 6c, we've got 12c4 equals 12cn, which means, 4 plus n should equal 12. So n has to be 8. That was fairly simple. 7a. So for n equals 8 and r equals 3, so n r minus 1 plus n r equals n plus 1 r. We're just showing this, we're not proving it algebraically, although I would like you to do that later. I think it's in one of the later questions. So they're saying 8c3 plus, 8c2 plus 8c3 equals 9c3. Which means, well, we could actually show this on our calculators. 8c2 is 28. 8c3 is 56, and 9c3 is 84. Let's double check, 28 plus 56 does equal 84. So that's done. 7b, says that we can then use this to show the other ones. So we've got 5C3, 5C4, and we're trying to find out what n is, NC4. So they've written this incorrectly. No, they haven't. So in this one, this n, this one's 5, this one's 5, which means this n plus 1 is here. So n equals 5 plus 1 equals 6. And that was for I. For II, let's re-highlight these. So those are our two n's, which is fine. N plus 1 came out as 11, which means n plus 1 equals 11, so n equals 10. That wasn't that bad.